Welcome you all to this second session on electronic digital communication classes. In the last class, we talked about different types of signals and different systems and how signals and systems are integrated. In this session, let us learn something about what this noise is. A noise is something which is unwanted, which is spurious. So this is static, and then when you see these TV channels, black and white and color, you see this kind of disturbance coming. Basically, it is a disturbance when you switch between the two channels on a TV or on radio also, audio as well as video, you will see this. So what actually is this noise? It is unwanted introduction of energy, okay, and this with the proper reception and reproduction of transmitted signals, when they do interfere. So many disturbances of electrical nature are produced in receivers, so they modify the signal in an unwanted manner. So what you see in television sets is called as a snow, or also called as confetti, okay. So we call this noise as confetti or noise. This is also called as snow in TV channel. So in pulse communication system, it produces unwanted pulses, which actually causes many errors. So noise can adversely affect the signal, and the efficiency of the systems will be reduced. So this is a general term, actually unwanted signal, and it is affecting the wanted signal. And it is random in its nature, and it exists in all communication systems. So let us go more into this. I think the noise what we are talking about, what you see here, is divided into what is known as external noise and internal noise. Then external noise is further divided into atmospheric noise, extraterrestrial noise, and man-made or industrial noise. Then this is internal noise, which is divided into thermal noise, short noise, transit noise, and miscellaneous noise. Let us look into each of them in a different manner. So there are number of ways in which you classify a noise. It can be actually divided. The noise, whatever we are talking, can be divided in terms of what is known as type, depending on the type, and source, depending on the source, the effect, relation to the receiver. So depending on what you are talking about, the noise is classified. So what we are talking about here is a man-made noise. External noise comes from the source over which we have little or no control. Then it can also come from industrial sources such as motors, generators, and over a period of time, all these devices, all these instruments, we talk something called as wear and tear. So over a long period of usage, there is a possibility of noise coming into that because the efficiency is being lost. Wear and tear comes. And it can also come from atmospheric sources, and due to random movement of electrons in a circuit. It can come from electronic components in a receiver such as resistors, diodes. These are actually a major cause of internal noise. Then noise level in a system is proportional to temperature and bandwidth, amount of current flowing in a component, the gain of the circuit. So this is the type, the source, and the effect and relation. This is how you will be seeing this. So the parameters, as I already discussed, it depends on the temperature and bandwidth of the circuit, the gain of the circuit. If the gain is very high, there is some amount of noise present in it. The resistance of the circuit, or impedance, and the amount of current flowing. So these are all the contributing factors, and the effect of noise is it degrades the system performance, both analog and digital systems, and then the receiver cannot understand the original signal. So this can be one reason. The receiver cannot function as it should be, and it reduces the efficiency of the system. So this is how we will be discussing about these effects. These are the different types of noise: the thermal noise, the short noise, noise temperature, and quantization errors. Let us see them in some while. This is a thermal noise. So this is a result of the random motion of charged particles in a conductive medium such as a resistor. This is generally created, as you can see, this is a picture of a noise. So this is generally in cables, impedance measurements, you will be finding this kind of errors. Then why is this coming? What is the reason? Because of movement of electrons, the kinetic energy will increase, which in turn increases the temperature. So that is the result that you are able to see. This is often referred to as white noise because it has a uniform spectral density across the EM spectrum. Short noise, number of photons per pixel increases. As you can see, generally this is a picture that they discuss as a number of, each of them is a pixel. The intersection of row and column is a pixel. More the number of pixels, the better would be the clarity. Nowadays, all of you must be all of you are all in the digital age, must be using lot of mobile phones. So in all your mobile phones, when you see, they write front camera and back end or rear camera. They say 5 megapixels and then 8 megapixels. So this is megapixels, 10 to the power 6. More the number, you must be seeing the advertisements, you all know much better about these mobile phones and their resolution. The higher the number of pixels, better would be the resolution. So that means a given signal or a data or information is represented by number of levels. More the number of levels are, more as the number of levels is increasing, you have a better resolution pictures. So this noise concept comes in when the number of levels is reduced, the noise dominates the signal. So we should have a better signal and less noise. So therefore we calculate what is known as signal to noise ratio. So when we calculate this signal to noise ratio, signal to noise ratio, it is referred to as S by N. We want signal to be more and noise to be less. That means your S by N ratio should be greater than 1. Okay. So there are ways, methods, techniques to minimize noise. Minimize noise or maximize signal. So these are the various ways that we will be looking at. Then noise temperature. So before we go to the noise temperature, it is important to realize that noise temperature of a component describes the additional noise that the component inserts into a signal before it is amplified. So before a signal is amplified, there is some amount of noise that is introduced by the component. So that thereby the temperature of the system will be increasing. So this is how usually for all this image processing, this picture is given. This is original picture. The image is a magnified portion. So compressed image, original image, and how it is compressed is what you can see. Okay. So now let us talk about something called as the atmospheric noise. What is this atmospheric noise? I told you already that noise is basically divided into external noise and internal noise. Okay, so this external noise can be further divided in various ways that you have already seen. So the best way to become acquainted is you can have also what is known as atmospheric noise. What is atmospheric noise? That is an extra noise, that is external noise. Okay, and what is happening is these radio waves, whatever you are talking about, the communication system, the communication of signals, okay, they travel through space consisting of atmosphere. So what happens? This atmospheric noise is basically spurious radio signals which are distributed in this atmosphere. Okay, and when they travel through this air, these different layers of the atmosphere cause some kind of disturbance, which you term it as a noise. So atmospheric noise becomes more pronounced or more for lower frequencies. Whereas it becomes less as the frequency is increased. So when the frequency is more than 30 megahertz, then the effect of this noise is this. So that is what we will be talking about this. Then another noise that we talk about, the next noise that we are talking about is referred to as extra terrestrial noise. What is this extraterrestrial noise? The sun radiates actually so many things our way that we should not be too surprised to find the noise is noticeable among them. So under normal quiet conditions, it's a large body. The sun's temperature is 6000 degrees Celsius on the surface. So it is therefore radiating over a very broad frequency spectrum, which includes frequencies for communication. So it is a constantly changing star, as you all know. It is a star which is changing constantly. Okay, so it undergoes cycles of peak activity, and even though the additional noise produced comes from limited portion of the sun's surface, it still be of an order of magnitude which is greater than that on a quiet sun. So because of this, what happens? There is a correlation between these sun peaks, sun at a high temperature, at a high and a quiet sun. Because of these things, you will have a noise introduced into the systems. So, okay, this is one relation. Then the other one is cosmic noise. So, the sun is changing, so it undergoes cycles of peak activity such as corona flares and sunspots. The peak activity like sometimes you will have excuse me. So because of this, there is some limited disturbances that is coming. Corona flares and sunspots. So these times the radiation of the sun is so much that it will interfere with our systems. So therefore, this is one source of a noise that you will be getting. Then what is the cosmic noise that we are talking about? Since stars are also suns and they also have high temperatures, they radiate. The stars are also like sun. So the stars radiate RF noise. RF means radio frequency noise. So what happens is this noise received is called actually a thermal or a black body noise, and it is distributed fairly uniformly over the entire sky. So this is called a thermal noise because they are radiating. The noise which is produced by them is called as a thermal noise, and it is distributed over the entire sky. Okay, it is distributed over the entire sky. This is one source of getting the noise. These are the various ways in which noise is introduced into our systems. Then, other than this, we also receive it from our own galaxy, the Milky Way, from other virtual points like quasars, pulsars and so on. Milky Way, you have some particles called quasars, pulsars, all these are cosmic elements. These are all known. They also produce, they also radiate, so we call that as galactic noise. All these come under what is known as the external noise. So Cassiopeia, two of the strongest sources, if you are interested in this area, strongest source of noise is from, you know, the constellations. So Cassiopeia A and Cygnus A, they contribute more towards this external noise. Now, we discuss something about industrial noise also. What is industrial noise? We are looking into the different sources. So in industries, in urban areas, within a frequency between 1 to 600 megahertz, in urban, suburban areas, the intensity of noise made by all these humans, which is created by any other source, is known as internal. So it can be, the noise can be emanated either from aircrafts, automobiles, or machinery, or sometimes leakage of electrical circuits, or any other powerful source. So these are the sources of error from the industries. So all these, whatever we discussed, the cosmic, what we discussed was atmospheric, sun, galaxies, industry, all these form what is known as external noise. They all come under external noise. So, now let us discuss about some internal noise. The internal noise that we are talking about, let us see. Under the heading internal noise, the noise is created by any of the active or passive devices under internal noise. This is a noise which is created by any of the active or passive devices in receivers. Where do you find this noise? In the receiver, isn't it? So you have, what do you have? You have a source, you have a channel, and then you have a receiver. This is the basic fundamental building block of any communication system, isn't it? So before the source is reaching the receiver, we have what is known as a channel. So before this, you also have an encoder. You can encode it and then give it. You can subway this. Here again, before it reaches, you have what is known as a decoder. Fine. So now what is it that we are talking about? There is a possibility of error encountered before it reaches the receiver. There is a passive or an active device found in the receiver that could be the reason for noise. Noise is randomly distributed. So random noise is proportional to the bandwidth over which it is measured. So we have a thermal noise. So the internal noise that we are talking can be a thermal noise, this is the noise which is generated in resistances or resistive components. Okay, and in the resistances, this is the noise which is created in the resistance, or it can be a resistive component. Or a resistive component. This is referred to as thermal agitation or a thermal noise. Thermal noise or thermal agitation. This is also referred to as a White or Johnson noise. It is due to the rapid and random motion of the molecules inside the component itself. It is coming because of the component, right? So the source of this noise is due to rapid and random motion of the molecules. Random motion of the molecules of the component itself. So in thermodynamics and all, when you see the temperature of the particle is expressed in terms of kinetic energy. Okay, so this is one reason, this thing. So now let's see, the next noise that we talk about could be any other noise that we talk is, the next noise that we are talking about is a short noise. What is meant by short noise? See, when we discussed about the thermal noise, it is only the only source of noise in decibels. The more important of all is short event, which leads to short noise. It is caused by thermal noise is by no means the only source. This is actually thermal noise is what you have seen it in receiver, right? You have seen this in the receiver. This is not the only one. We have a short noise which is more important. Why the short noise is coming? The short noise is in an amplifying devices. This is found in amplifying devices. Okay, it is caused, why is it caused in amplifying devices? Because of random variations in the arrival of electrons or holes. It can be either electrons or holes, okay, at the output. Okay, it is actually observed in an amplifying device. So when a signal is being amplified, it is supposed to sound as though a shower of lead shot were falling on a metal sheet. Hence the name shot. That means, let us see what I am trying to say is, when a signal is amplified. When a signal is amplified means what? The gain of the system is increased, isn't it? Is increased. So suppose you are taking a voltage gain. What is voltage gain? AV is output voltage by input voltage. When the gain is increasing, that means output voltage is increasing. So voltage is increasing means more number of electrons are coming and hitting the output. So it's a surge of, it's like a shower of majority carriers reaching the output. These majority carriers can be either electrons or holes depending on what the case is, and hence it is known as short. So this is another way in which you look at the noise. Then there is one more thing called as transit noise. Let us see what is meant by a transit noise. As the name indicates, this is a transition time. Transition time between input to the output through a doping medium. If the time taken by an electron to travel from the emitter to the collector of a transistor becomes significant to the period of signal, then at frequencies, this is what happens. So what is it that we are talking about? If the time taken by an electron to travel from the emitter from the emitter to the collector, from the emitter to the collector of a transistor becomes significant compared to what? To the signal being amplified. From the emitter to the collector, it is reaching. So if that time taken is compared to the time it takes for the signal to be amplified, that is when will it happen? For frequencies which are very high frequencies. Okay, then what happens? The noise becomes significant. It's more time it is spending in the transition. Therefore, there is a possibility of noise being felt here. So this is this thing. So this is called transit time effect. So the minute currents are induced. So therefore, the noise is more in these cases. Another thing that we talk about different noise is flicker noise. What happens is at low audio frequencies, you must have seen this in audio systems, the hiss sound you hear whenever you change between the two stations, between two frequencies. That sound what you hear is a flicker sound. Okay, this is poorest form of noise. Okay, it is actually proportional to emitter current junction temperature. So these are all the different noise